Now we are going to study about capacitance in parallel or capacitors connected in parallel. So capacitance in parallel. Now understand what. So we are going to consider 3 or 4 capacitor. We connected them parallel to a battery. What will be the effective capacitance? That is effective. That மூணையும் combine பண்ணா என்ன effective கிடைக்கும் அப்படின்றத mathematically derive பண்ணுவோம். So we are going to derive the expression for effective capacitance when the capacitors are connected in parallel. Okay. So let us consider 3 capacitor. Let us consider 3 capacitors C1, C2 and C3 connected to a battery of V volt. Appo V volt to a battery. We have 3, let us take 3 capacitor. C1 capacitor, C2 இன்னொரு capacitor, C3 இன்னொரு capacitor. All 3 are connected in parallel. The C1, C2, C3 connected parallel to a battery of V volt. Okay. What we should understand, it is an electrical circuit. When they connected in parallel, normally current splits up. Here, current is nothing but rate of flow of charge. If current split, charge also will split. This is charge Q1, this is charge Q2, this is charge Q3. That's all. Because C1, C2, C3, the capacitors are different. Charge will split. Current split charge, total charge, I equal to total charge by time. But total charge Q charge, when they pass through these capacitors, when they connected in parallel, their charges split into Q1, Q2, Q3. Whereas potential is same. Parallel component nale, it's a common. Potential is same. V is same for all the instrument. Okay. Namakku formula theriyum. C equal to Q by V is the basic formula of capacitance. Appo Q1 is the charge passing through the capacitor. Formula is C1V. Q2 is the capacitance of the second capacitor, which is C2V. And Q3 is the charge passing through the third capacitor, C3V. Appo Q is the combined charge. Motta charge. Appo Q edukku equal nu pathena Q1 plus Q2 plus Q3. It's clear, no? Total charge, moona split edge. Q1, Q2, Q3. That's all. But Q is nothing but C effective. Effective capacitance is, let us take it as Cp into V. Let us substitute this value. Cpv equal to C1V plus C2V plus C3V. So total charge will be equal to sum of individual charges found in the capacitor C1, C2, C3. V a common at cancel panta. Effective capacitance in parallel will be equal to C1 plus C2 plus C3. Conclusion, when the capacitance are connected in parallel, charge splits. Potential same. Charge splits. Q split out. Potential constant. This is understand we can able to write. Split another add panna total charge. Q is CPV, Q1 is C1V, C2V, C3V. Upon conclusion, the effective capacitance is equal to effective capacitance is equal to equal to sum of individual capacitors. Individual capacitors. That's all. This is the way we can derive the formula to calculate effective capacitance. Thank you for listening.